You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your IT Fundamentals certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. In this episode, we introduce three fast-evolving categories of computing devices: augmented reality, virtual reality, and the Internet of Things. These technologies are transforming both consumer electronics and enterprise infrastructure. They expand how we interact with data, how devices communicate, and how automation is deployed in real-world environments. From smart thermostats to immersive simulations, these systems represent a growing share of the technology landscape and are increasingly relevant in modern IT support roles. These technologies are covered in Domain 2 of the ITF Plus exam under Common Computing Devices. You may encounter questions asking you to define these technologies, recognize device types, or match examples to specific use cases. They are often tested through scenario-based and vocabulary-based questions. Even at the fundamentals level, awareness of these technologies shows that you understand not only what IT was, but what it is becoming. Augmented reality, or AR, refers to the overlay of digital content onto the real world. Rather than creating a new environment, AR enhances the user's perception of their existing surroundings. This is done using phones, tablets, specialized glasses, or headsets. AR can add navigation prompts, instructional diagrams, or virtual objects to your view of the physical world, allowing real-time interaction with both digital and tangible elements. AR has growing use in business and education. In retail, AR apps let customers view product specs by scanning items in-store. In maintenance, technicians can use AR headsets to view schematics or step-by-step instructions while working on equipment. Educators use AR to demonstrate science concepts with 3D overlays, and field workers use it for diagnostics or remote collaboration. The ability to add helpful data to real-world views improves clarity and productivity. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Virtual reality, or VR, is a technology that immerses the user in a completely digital environment. Unlike AR, which adds to the real world, VR replaces it. Users wear headsets that block out physical surroundings and simulate an entirely new visual and auditory experience. These environments may be fictional, realistic, or data-driven, and they can simulate everything from space missions to product design spaces. VR use cases span many industries. In healthcare, students use VR for surgical training. In architecture, designers walk through digital models of buildings before construction begins. In corporate settings, teams hold virtual meetings with shared whiteboards and simulated spaces. Entertainment remains a major application, with immersive gaming and virtual storytelling reaching new levels of interactivity. VR creates high-impact experiences that improve training, exploration, and collaboration. The differences between AR and VR are important to understand. AR adds digital content to a real environment and allows multitasking with the physical world. VR isolates the user in a fully digital space and requires full attention and specialized gear. AR can run on mobile phones or tablets, while VR depends on headsets with built-in sensors and displays. These distinctions affect how each technology is deployed and what environments they are best suited for. The Internet of Things, or IoT, refers to physical devices equipped with sensors, software, and connectivity that allow them to collect and share data. These devices often serve one specific function and operate with minimal user interaction. IoT devices can be as simple as a smart thermostat or as complex as an industrial automation system. Their common feature is data collection and communication through a network. Examples of IoT in daily life are everywhere. Smart thermostats adjust temperature based on usage patterns. Health trackers collect biometrics like heart rate and sleep duration. Smart doorbells notify homeowners of visitors and stream video footage. Lights, plugs, refrigerators, and voice-controlled assistants all fall under the IoT umbrella when connected to a network and capable of remote control or automation. Businesses use IoT devices to monitor, optimize, and automate. In factories, environmental sensors track humidity or air quality. In logistics, IoT tags help track inventory and delivery status. In agriculture, soil sensors inform watering schedules. Energy companies use IoT to balance grid loads in real time. The applications span nearly every sector and are continuing to grow rapidly. IoT brings intelligence and responsiveness to systems that once operated in isolation. Connectivity plays a critical role in all three technologies: AR, VR, and IoT. These devices rely on fast, stable network connections to function effectively. Many use Wi-Fi, Bluetooth, or cellular networks, while some industrial devices communicate using specialized protocols like Zigbee or LoRaWAN. In many cases, devices are designed to interact with cloud services in real time, requiring low latency and consistent bandwidth to deliver seamless performance. Processing and storage needs vary by device type. VR headsets typically require strong onboard processing, particularly for graphics rendering, which demands a high-performance GPU and ample RAM. AR applications can range from simple overlays run on mobile devices to complex headset-based platforms with built-in processing. IoT devices, in contrast, are usually optimized for efficiency and include just enough firmware and memory to perform their specific function, sending most data to the cloud for analysis or storage. Security is a major concern for these connected technologies. Many IoT devices are shipped with default usernames, weak passwords, or limited encryption. AR and VR systems may store sensitive user data, including location, preferences, and recorded media. Without proper configuration, these devices can become easy targets for attackers. Security best practices include firmware updates, network segmentation, secure communication protocols, and disabling unused features. Firmware and update management are key responsibilities in supporting AR, VR, and IoT environments. Updates may improve performance, enable new features, or patch critical vulnerabilities. Because many devices lack traditional interfaces, updates are often deployed remotely via mobile apps, cloud services, or local hubs. Missed updates can leave systems exposed or unable to function properly, making update management part of ongoing device lifecycle support. Troubleshooting these devices can be challenging due to their diversity and limited standardization. Some rely on proprietary software, non-standard connectors, or third-party apps that must all function together. Support may require checking multiple layers, from local device logs to mobile apps to cloud dashboards. Additionally, documentation quality varies by manufacturer, requiring IT professionals to rely on forums, user communities, and experience when solving problems. The rise of edge computing supports more efficient IoT deployments. Edge computing involves processing data closer to the source on the device or a nearby local server, rather than relying entirely on cloud infrastructure. This reduces latency, saves bandwidth, and improves response times in time-sensitive applications like industrial control, smart vehicles, or medical monitoring. As IoT grows, edge computing helps manage the scale and complexity of real-time data. All three device types, AR, VR, and IoT, have a direct impact on IT infrastructure planning. The number of connected devices increases network load, requiring better Wi-Fi coverage, more IP address management, and stronger security policies. Systems must be in place to enroll, authenticate, monitor, and support these devices. This introduces new responsibilities for IT teams, including managing smart device firmware, user access policies, and integration with existing enterprise systems. The ITF Plus exam may include questions that ask you to define or identify AR, VR, or IoT devices based on a brief scenario. You may be asked to match a device with a business use case or identify which system presents a specific security risk. Other questions may highlight connectivity concerns, prompting you to recognize what infrastructure is needed for full functionality. Reviewing examples and terminology can help prepare you for these question types. These technologies are not limited to niche industries. They are becoming common across business, education, retail, logistics, and healthcare. A technician may soon be asked to support an AR-based training tool, a VR onboarding platform, or a fleet of IoT-enabled environmental monitors. Understanding the roles, needs, and support structures of these systems prepares you for a broader set of responsibilities in modern IT environments. To summarize, augmented reality, virtual reality, and Internet of Things devices represent an expanding frontier in computing. Each technology brings its own use cases, challenges, and requirements, but they all share a reliance on connectivity, real-time data, and integration with broader systems. As these technologies become part of everyday IT, familiarity with their function, purpose, and support needs becomes essential for both exam success and real-world readiness. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.